Today we are working on graphing inequalities. And so what I want you to think about is what these inequalities really say. If we go back to notes that we took a little while ago, we remember that this symbol means greater than, we've got less than, we've got greater than or equal, and less than or equal. Something else important to know is that when you are graphing these on a number line, you have to use certain points. When you are graphing something that is greater than or less than, you are going to use an open point, because what that open point means is that you are not including the number itself. Okay, you're including everything up to that number or down to that number, but you are not including the number itself. So an open dot for greater than or less than. When it can be equal, you are using a closed dot or a colored in point. So notice how there's more ink to write the equals to part of the symbol. There's also more ink to write the closed dot. Okay, so when we are graphing inequalities, if you have a symbol that looks like greater than or less than, that is an open dot. And if you have greater than or equal to or less than or equal to, that is a closed dot, okay? That is really important to remember. Remember, more ink when you have it equal, okay? So the other important thing to remember is that we can read these as words. We can translate this into words. So this says x is greater than 3. So we have x is greater than 3. And since we know that x is greater than 3, we're going to list 5 numbers that x could be, just to kind of help our brain wrap around what x could be. So think to yourself, any numbers that are greater than 3, we can list right here. So I want you to think to yourself while I'm thinking to myself, x is greater than 3. Well, 4 is greater than 3. 100 is greater than 3. 16 is greater than 3. 3.1 is greater than 3. And 3.4 is greater than 3. Okay, so those are all numbers that are greater than 3. So here's what your process is when you're graphing an inequality. You are going to decide what dot to use on the 3. Since this is greater than and not equal to, you are going to use an open dot on 3. So I'm going to find 3, and it's kind of tiny little numbers. I'm going to find 3. Here's 3, an open dot because it's greater than. Now, I am going to draw a number line on top of my number line. I'm going to draw an arrow on top of my number line to show which direction these x's can go. Right? Now, here's the thing. X is any number greater than 3. So we could graph 5, we can graph 6, we can graph 7, any number greater than 3. So here we know 4, we know 5, we know 6, we know 7, we know 8, we know 4.5, we know 5.5, we know 6.5, 7.5. All of those numbers are greater than 3. All of them. Even, 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9. All of those numbers. And if you fill in enough numbers that are greater than 3, pretty soon what you have is just a solid line for all of the numbers greater than 3. Okay, that is how you graph an inequality. This is what it should look like, an open or closed dot, and then an arrow in the direction of the bigger or smaller numbers, whatever way it needs to go. Okay. All right. Next one. This one says 1 is greater than x. So this says 1 is greater than x. Since 1 is greater than x, we know that x has to be less than 1. It's the same thing. X is less than 1. If 1 is greater than x, x has to be less than 1. So let's write numbers that x could be. So if x has to be less than 1, x could be -2, -1. It could be 0. It could also be 0.9 because that's less than 1. It could be 0.8. Could be Negative 52 could be lots of numbers. Okay, but now we have to graph this. Now remember, this could not be equal. It does not say it's equal to 1 or equal to x. It's only greater than and less than each other. So I'm looking at this and I'm going to use the open dot, the open circle, and I'm going to put it at 1. Okay, now x is less than 1, or the other way, the original way. 1 is greater than x. So anything that x is, we have to make sure that it's less than 1, or that 1 is the biggest it could possibly be. It can't even really be equal to 1. Okay, because 1 is bigger. Okay, so I'm going to start graphing these points. Negative 1, negative 2. We also know it could be negative 3, negative 4, negative 5. We did 0. We also said 0.9. That's right here. 0.8, 0.7, 0.6. And again, if we filled in all the things that x could possibly be, we would get a solid line for all of the numbers less than 1, because x is less than 1. All of these numbers are less than 1, and all of these numbers we can continue on forever in this direction would still be less than 1. All right. Next one. X is less than or equal to 7. X is less than or equal to. Now this one's a little bit different because it says less than or equal to. Okay, so x is less than or equal to 7. So let's start out with numbers, 5 numbers that x could be. What is less than 7? Well, 6, 5, 4, negative 14. Just thinking of numbers that are less than 7, 0. Now here's the thing though. It can also be equal to 7. Since it can be equal to 7, we're going to include 7 in the numbers that it could be equal to. Okay, so remember, when we have something that can be equal to that number, we are going to use a solid point, a colored in point. All right, and sometimes people call it a closed point, closed dot. So I'm going to put my closed dot right on 7, and then I'm going to think about what all my x values could be. So x could be 6, it could be 5, it could be 4, it could be negative 14 way down here, it could be 0, it could be all these. So if I filled in all of the values that it could be, I would have a solid line going to all the numbers less than 7, and it could also be equal to 7. That's why we have a closed dot. Okay, our last one. Negative 2 is less than or equal to x. Negative 2 is less than or equal to x. The other way we can write this, if we can flip the whole thing around, x has to be bigger though, because remember the bigger part of the sign is to x. So x is greater than or equal to negative 2. X is greater than or equal to negative 2. So now we got to think about numbers that could make that true. All right. So what could x be? If x is greater than or equal to negative 2, well, it could equal negative 2. Now we've got to think of numbers that are greater than negative 2. 5 is greater than negative 2. Negative 1 is greater than negative 2 because here's negative 2 and here's negative 1. 6, 0 is greater than negative 2. 5.8 is greater than negative 2. Lots of numbers. You can come up with an infinite amount of numbers that are greater than negative 2. So now we've got to graph it. Since it is greater than or equal to negative 2, we put a point on negative 2. And it's going to be closed because it can be equal to that value. Okay, now we want numbers, x is greater than, we want greater than or equal to negative 2. So I'm going to graph all the numbers that are greater than negative 2. All of these numbers are greater than negative 2. And if I fill in all these numbers, 7, 7.1, 7.2, 7.3, 7.4, and I just picked a random spot because that's greater than negative 2, I could fill that in and get all of the numbers. And so really what I graphed was x is greater than or equal to negative 2. But the original way to say this was negative 2 is less than or equal to x. So negative 2 is the smallest it can be. X has to be all the numbers that are bigger. Okay, so first ask yourself, what does x or the variable have to be? Is x bigger or smaller than the number given? You might have to flip it around like we did here to make sense of it. Second thing, open or closed dot. If it is equal to the number, if it can be equal to the number, you're going to have a closed point. If it is just greater than or less than, it is going to be an open point. Next, you've got to decide where all the values are. Are they on the greater side or on the less side? All right.